topic. Write down topic. Equilibrium of floating object. Equilibrium of floating object. Equilibrium of floating object. Right. There are three types of equilibrium that can be seen in the environment. What is the tree? It can be described as this. By describing the situation of this world, we can tell what are the equilibrium. So, first one is unstable equilibrium. This is stable equilibrium. Then you can say neutral. Right? It's unstable because when we push some, give some displacement, it comes to down because its potential energy is high. So in this case, if we give the simple small displacement, it's go area, then come to the initial position. But this one is not going the always remaining, which if we give the small displacement, remain in that place. Okay, it's stable, and neutral. Right. Write down. Write down topic equilibrium of floating object. Then write down there is a equilibrium. There is a three equilibrium. There is three equilibrium states can be found. There are three equilibrium state can be found. Right. Right now this one. Unstable equilibrium, stable equilibrium, neutral equilibrium. Okay. In the floating object also that can be discussed. So in the floating object also having unstable, stable, and neutral. It's depend on the location of the G and G dash. G means the gravity center of gravity, and the G dash is the center of buoyancy. Right? Okay, right now. Okay. Draw this tree diagram and write down the equilibrium. Then write. So the floating object, if the center of gravity is located before the center of buoyancy at U, and center of gravity acts 𝑚𝑔. If we give the push, it's coming to this state. So it's situated like this. So the gravitation center of gravity, it's like this. Then G dash, center of buoyancy. From that, the upthrust act like this. There is a small case because the Mg and U act as the force couple. Therefore, it's bent over to the, it's bent to the direction that we give the small displacement. එහෙනම් අපි small displacement එකක් කරගමු පැත්තටම මෙයාගේ force couple එකක් ඇවිල්ලා කරගෙනවා. UNH. එතකොට මෙයා වැටෙනවා මේ පැත්තට. එතකොට මේක ඇවිල්ලා මේ වගේ නේද? Unstable equilibrium එකක්. So if we give the small displacement, it come to the down. So it's also coming to the down. That is this float. If we consider this floating object, this is in unstable equilibrium. Okay. After writing this, write down simple A part. Simple A. If center of gravity capital G, center of gravity capital G is above center of buoyancy capital G dash center of gravity capital G is above center of buoyancy capital G dash center of buoyancy capital G dash while floating the object vertically a small angular displacement creates a small angular displacement creates a force couple capital U and mg and it support the direction of the tilt the direction of the tilt. Therefore, the object is in unstable equilibrium. Therefore, the object is in unstable equilibrium. Unstable equilibrium. Right. Write down the draw this one. Draw this one. Okay. Then write. Then if we think like this, so the upthrust act before the center of gravity, before the engine. So the G dash is upper part in the body. So if we give the small angular displacement, it creates what? It's bent like this, but there is U act into this direction, then mg act into downward direction. Because of that, mg act downward direction, so it creates force couple to another direction. Because of that, it come into the stable position. So if we give the small displacement, it come into the original position. Therefore, it is called what? Stable equilibrium. Stable equilibrium. So write down B part. If capital G is below, if capital G is situated below G dash, while floating vertically, while floating vertically, small angular displacement will create force couple the opposite direction of the tilt. Therefore, object will return to the original vertical position. This is stable equilibrium. This is called stable equilibrium. Okay, write down this one. Okay, draw this one. Then, if we discuss situation like this, the G and G dash located in same point. So the upthrust and mg is like this. So if I gave the angular displacement, it will create mg and there is the force G dash upthrust. Because of that, if we give the small angular displacement, it will rotate. So there is no, it's not coming to the original position because the G and G dash on the same point. If we give the any position, it remains the that position. That means it is neutral equilibrium. Right? So write down if capital G and G dash C part, if capital G and G dash align while floating vertically, small angular displacement Floating vertically. If we give small angular displacement, the object remain. The object remain. If we give the small angular displacement, the object remain in that position. In that position, there is no force couple. There is no force couple. Therefore, it is the neutral equilibrium. Therefore, it is the neutral equilibrium. Right. Write down C. Draw this one. Okay. Then write down a point. A point. To maintain a stable equilibrium. To maintain a stable equilibrium, it is necessary. It is necessary to place center of gravity capital G below to the space. Center of gravity capital G below to the capital G dash. Capital G dash. Okay. This is the equilibrium of the floating body. Right. Then write down another topic. Hydrometer. What mean by the hydrometer? We are using the hydrometer to get the density values, right? Density of the milk, density of the battery acid. So we use the hydrometer to that one. So it is the floating object. So we place that one and get the density values. Density values. So write down hydrometer can be introduced as a simple instrument. As a simple instrument. Simple instrument that can be used to measure. That can be used to measure density of the liquids. Right. It's like this. So there is a scale, but the scale is not linear. Scale is like this. So scale is not linear. We can discuss after that. So this is bulb loaded with the lead balls. So it's flowed in vertically in the liquid. Okay. Okay. Write down this one. Thin, long, straight. With scale. මේ කුරක් ඔය එකක් තියෙන එකේ ඒකේ මෙන්න මෙහෙම ස්කේල් එකක් තියෙන ස්කේල් එක ලීනියර් නෑ ස්කේල් එක ලීනියර් නෑ බට් මේ වගේ ස්කේල් එකක් තියෙනවා right එතකොට මේකේ ලොකු බල්බ් එකක් තියෙනවා යට තව බල්බ් එකක් තියෙනවා ඒකේ LED balls පුරවලා තියෙනවා right okay know this one so what are the forces there is a U that means center of buoyancy in this direction so center of gravity acts like this. Therefore, the object in stable equilibrium. Okay, know this one. So this is in stable equilibrium. Write down. So why we are using the lead balls to the bulb? Because we have to maintain the G center of gravity, the lower. So therefore we use this lead balls. So the center of buoyancy in the upper part because there is a low there is a this bulb is low because ඒක ලොකු වුණාට පස්සේ එයාගේ center of buoyancy කුඩට යනවා right but that ටිකක් ලොකුයි right then write down the hydrometer is in stable equilibrium while it floating the lower bulb loaded with the lead balls it make the hydrometer to float in stable equilibrium. When the bulb volume is higher, okay, volume එක වැඩි. That gives the sufficient upthrust to the body the thin long stem the thin long stem, this one, is increasing the sensitivity of the reading. Is increasing the sensitivity of the hydrometer. Sensitivity of the hydrometer. So why this gap is not linear? Because if we float this hydrometer to the lower density liquid, it's going down. Why? The sufficient upthrust is not enough because it is going down. Therefore, the liquid is in higher density, it's going up. The liquid is low density is going down. Because of that, the height of the float is inversely proportional to the density. The density is higher, it's got up the smallest uh, distance. So density is lower, it's going down. Therefore, the distance is higher. Because of that, there is no linear scale. The gap is higher. So write down the gap between the consecutive markings of hydrometer is not linear because there is no linear relationship between the height of the immersed portion of hydrometer it is inversely proportional to the density. Okay, I take the value x, y, and z. So I give the density is 800 kgm minus 3, 1000 kgm minus 3, and 1200. So what is the x, what is the y, what is the z? Okay, give the answer. So write down that also. Therefore, x is 800 because it's going down. 800. This is 1200. This is 1000. Okay, write down this one. It because we can prove that one also. I take this one. So I take the area of this one is A, and the height of this stream is H. The value of this density value of this one is rho. So I can take the volume of this one is V. So I can take flotation, force equilibrium. Considering force equilibrium. U equals to mg. Therefore, U mean V into A H. So the volume rho G equals to mg. Mg is the constant. No? So we can tell V plus AH equals G to G cancel out M over rho. Therefore, the H is proportional to 1 over rho. 1 over rho. Okay. Okay. Right on this one also. Okay. Then we can do the problem. Write down that also. Okay. So this one. So this is the hydrometer. We can get that one. So this is the hydrometer. So you can see if we take this one. So it's the use for triple scale alcohol tester, hydrometer for wine, beer for and this one the making it that also it can buy. So the supplies there is data and other things. So it can use the hydrometer test. It also used to measure the density of the soil. So this is idol. There is a there is a you can see there is a lead balls, and there is a some kind of wax only. So when getting upward, so there is a bulb. So make a wax dala මෙහෙම මේ මොනවද lead balls දාලා කරන practical එකකුත් තියෙනවා. There is a practical number 8 of. So there is a scale. We can see the scale is not linear, like this. So there is a test sheet also. See, there is no linear scale. There is no linear scale. So the important part is this one. So this one. So there is a table also, hydrometer kit, and there is the values and the apparatus like this. So this is the hydrometer. Right. Then write down. So let's do the some kind of problem. write down this problem. A hydrometer immersed, a hydrometer immersed, hydrometer immersed in the water, in the water, 6 centimeter above its calibrated steam, calibrated steam, and it float in oil density with density, float with in oil with density 0.8 GCM minus 3, 0.8 GCM minus 3. The 4 centimeter 4 centimeter is above the calibrated steam, above the calibrated steam. That means there is a hydrometer, it's floating, so the in it floating in the water, water mean 1 GCM minus 3, no? So it's like this. In water, it's like this, 6 centimeter. So in the oil, when it comes to the oil, 0.8 GCM minus 3, it's like this. Right. It's like this. So this is 4 centimeter. Okay. Then write down what is the length of what? Then write down the hydrometer is immersed in the water 6 centimeter above its calibrated steam, and in the oil uh, 0.8 GCM minus 3 above its 4 centimeter above its calibrated steam. What is the length of the length not immersed in calibrated steam, when it placed to when hydrometer placed the density of 0.9 GCM minus 2 in the liquid, density of 0.9 GCM minus 2. When hydrometer in liquid 0.9 GCM minus 3. මෙන්න මෙහෙම මේකේ in this liquid, the water, there is a 6 centimeter above this one. So there is a 4 centimeter above this one, and there is a x centimeter above this one. Find the x. So when it in zero point 0.9, liquid 0.9 PCm minus 2. Okay, do this one. We can take this one as like this. I not considering this bulb. So I will consider there is area A. So I take the total height as h. So this one is h minus 6. Q equals V rho G, and also U equals mg. V rho G equals mg. So G to G cancel out. P mean the h minus 6 A rho mean 1 into G cancel out. So this is same number 1. So consider this one. This case U equals V rho G. V rho G equals m. P mean h minus 4 into A into 0.8 equals m. It's number 2. So when you consider this case, h minus x, so I can found the h in this case. So I equal to 1 equals to h minus 6 a into 1 equals h minus 4 a into 0.8. So a to a cancel out. So h minus 6 0.8 h minus 3.2. So h getting this word. So 0.2 h equal h going this side h minus 3.2. That means 0.2 h equals 6 minus 3.2 means 3. 2.8. 2.8 h equals to 14 centimeter. So h equals to 14 centimeter. So this case, I take the for this one h minus x into a into 0.9 equals to m. I take as this number 3. So I equate first one and third one. So h minus 6 into 1 a equals to h minus x a into 0.9. H mean 14. 14 minus 6 a to cancel out equals to 14 minus 6.9. So this one is 8 now. 8 14 minus x over 0.9. So 8 over 0.9 14 minus 6. Okay, this answer. So for this case, I think your answer is correct. Yes, 5.11 equals 5.11. Okay, write down. Yes, your answer is correct. Then write down the change of upthrust with, then write down the change of upthrust with change of upthrust with the motion of the liquid container. Force of upthrust, force change of the upthrust with the motion of liquid container. Motion of liquid container. So if we consider this is the last part. So if we consider the liquid container, it having a water container and the object is floating. Object is floating in that. Mg and U. When it going the when it is in rest or it is going with the uniform velocity, U equals that there is no change. U equals V rho G. We know that. But if we travel with the acceleration or deceleration, there is change of this result. So okay, write down a body of fluid, a body of fluid. Write down A part, this simple A part. A body of fluid, stationary or moving vertical with uniform velocity. Stationary or moving vertically with uniform velocity. Therefore, we can tell it is U equals 0 G. U equals 0 G. Okay, draw this one and write this one quickly. Okay, write down the first. Then write down P part. A body move upward with uniform acceleration. A body move upward with uniform acceleration. Upward with uniform acceleration. What is the U? U equals P rho G plus A. The upthrust getting high. Right? P rho G plus A. Therefore, we have to apply the G as the effective gravitational acceleration. Then when it travels the acceleration to downward. So what is U? U equals V rho G minus C. Write down the part C. When a fluid body going downward with uniform acceleration. going downward with uniform acceleration. Right. Okay. Draw this one and write this one. Draw this one and write this one. Part C. Okay. Then write down part D when it going gravitation acceleration. Okay, write down. Going vertically downward with gravitation acceleration G. Going vertically downward with gravitation acceleration simple G. Going vertically downwards with gravitation acceleration simple G. Right. What is the upthrust? What is the effective gravitational constant? G minus G. G minus G mean U. U equals 0. U equals 0. Why? U equals V rho G minus G. Therefore, V rho 0. U equals 0. That's why there is no pressure inside the liquid when it fall gravitational acceleration. There is no uh, pressure. Therefore, pressure is create the upthrust. We know the Archimedes principle and the derivation of the Archimedes principle. We told the pressure creates the upthrust. Therefore, there is no pressure inside any point of the liquid. Therefore, there is no gravitational acceleration, and if body is going gravitational acceleration, there is no upthrust. Okay, upthrust is 0. Okay, write down. Write down. Write down as a point. Show that an object floating in beaker. An object floating in beaker. An object floating in beaker. And its height does not depend on the motion of the beaker, and its floating height not does not depend on the motion of the beaker, motion of the beaker, motion of the beaker. Right. Okay. Then write down another case. When it is in stationary position, consider the cross section as capital A. Cross section as capital A. The density of the liquid is rho. The density of the liquid is rho. And the floating height as symbol H. Right. Considering this case, floating height as symbol H. Okay. Considering this case, so I can tell U equals 0 G. U equals 0 G. What is U? U equals to what? This this volume. And also U equals to mg. Okay, mg and U. So I will write U equals what? H into A. The floating volume is H into A, right? Height and cross section. Rho G, V rho G equals mg. Cancel out. H equals m over A rho. H equals m over A rho, right? Like that. So when it float like when it go the I consider this case. So when it going downward or upward with uniform acceleration. So let's find again the what is the immersed volume, immersed height. Okay, it's like this. So I consider it as triple x. Right. A. So when it travel upward with uniform acceleration. So I can write considering floating body. I cannot take this one. This is horizontal vertical force equilibrium. I cannot get that one. Why? We have to apply F equals ma, right? When it travel it in acceleration, we have to apply F equals ma. Apply F equals ma to where? To upward direction. It's getting upward. So U minus mg, U minus mg equals ma. So U equals mg plus a. So we know what is the U? U equals what? U equals what? Previous case we have discussed. G plus F. G plus F, no? U equals V rho G plus F. Therefore, I can take V mean X A. The floating height volume is X A rho G G plus F G plus F M G plus F. So this one to this one cancel out. Therefore, this gives the X equals to M over A rho. It's the same result as previous because of that there is no floating height difference when it travels with the different cases. Okay, right. Okay, write down this when traveling with uniform acceleration to upward. Okay, write down this one. Therefore, there is no difference create when it travels different motion. Different motion condition. Okay. Right up. Better. Better. Write down when write down when an ice cube floating on water, when an ice cube floating on water, when it melts, water level of the container, okay, when it there is ice cube, after it melts, the water level increase or decrease? It it remains same. It remains same. Why? It remains same. If this ice cube is floating on the water and it melts, the water level does not vary. The water level does not vary. Okay, right now does not change. Does not change. Let's do. Is it correct or not? Okay. When it considering the ice cube, so I'll take it as this. So it's floating. The mass is mg and the thrust is q. So I take as the volume as capital V. So mg equals what? V rho g. V rho g. So g to g cancel out. V equals m over rho water. Right. We know the equilibrium now. So if ice cube got melt, it produce volume of water. So rho W equals MOV. Therefore, V naught equals M over rho W. The displaced volume of the water equals to the volume given. ඒ කියන්නේ අපි මොකක් හරි ඔබ්ජෙක්ට් එකක් දාපුවම මේක ඩිස්ප්ලේස් වෙනවානේ බෝඩ් ටික. ඒක තමයි මේ V කියන්නේ. මේක මෙල්ට් වුණාට පස්සේ හම්බ වෙන වොලියුම් එක තියෙනවානේ. ඒක තමයි V dot කියන්නේ. So they are equal. Therefore, there is not change in the water level of container. Okay. Draw this one and write this one. These are the important points to the MCQs. Okay. Okay, then write on the ice cube. Another point on the ice cube contained with air weight or air cavity inside when floating on water. When floating on water, if it melt, water level get what? Increase or decrease or not change. So mass of this one is I take as the mg, the water height ma, right? Decrease, yes. Mi plus ma equals what? V rho g. V rho water g. Therefore, V equals 1 over rho is cancel out now. Mi over ma. This is the volume which displaced. So after it melt, it produce water. So density of the water equals volume of water equals V naught. Rho W equals M I over V naught. V naught equals Mi over rho W. See, V is higher than to this one. V is higher than to this one. Right? Therefore, the water level decrease. Okay, write down. Right. Then write another point. When 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 there is a floating object inside the ice cube or inside the on the ice cube if ice cube got melt the level of level of water getting what I mean floating object mean it's like a plump or like this. It is floating. So ice cube in this like this. The floating object is like this. I take as the volume of this one is V1 and V. So it is floating object. So it having a mass m1g and also mg. So the updrafts are acting only V rho g. So let's think about that one. m1g plus mg equals to V rho g. The displaced volume m1 m over rho. Okay. When ice cube got melt, when ice cube got melt, it provide V naught volume of water. Right? It's produced V naught volume of water. So M equals or rho water equals M over V naught. V naught equals M over rho W. It's rho W, no? So in this case, M1 over rho W, M over rho W equals V. This one provides only this content. So now the floating object is floating in the water. Right? When it floating in the water, it also displays. ඒ කියන්නේ මෙයාත් පාවෙනවනේ දැන්. අර ටික ඔක්කොම දිය වුණාට පස්සේ. එතකොට ඒකෙනුත් මෙයා දෙනවා මේ the mass is mg you considering this one rotation of an object u equals v rho g mg equals v rho g displaced volume is m1 මේ තමයි displaced volume එක කියලා කියන්නේ. Right? Displaced volume plus the melted volume equal to this one, right? Therefore, it also equals to this one, right? Melted volume plus displaced volume equal to what? Water displaced initial. Therefore, there is no change, right? ඒ කියන්නේ උඩ මොකක් හරි පාවෙන ඔබ්ජෙක්ට් එකක් තිබ්බොත් එහෙම ෆ්ලෝටින් ඔබ්ජෙක්ට් එකක් තිබ්බොත් එහෙම there is no change, right? Okay, write down all the things. Write down the another point. Ice cube contain coin on the ice cube contain coin of the top of it or inside it. If it melt, the water level getting increased. If it melt, the water level getting increased. Water level get increased. Okay, right. So I think it not need to draw because it's although the similar sense. So if we push the ice cube downward and it got released, the water level getting increased. And අපි කාසි දාපු හින්දා කාසි හින්දා ඒක පුෂ් කරගෙන ඉන්නේ. කාසි යටට යනකොට එයා එහෙම කලින් පුෂ් කරගෙන හිටියට වඩා පොඩි ෆෝස් එකක් තියෙන්නේ. මොකද අප්‍රස් ෆෝස් එක. ඒකෙන් ඩිස්ප්ලේස් කරන මේ වොලියුම් එක මේ කොයින් එකේ වොලියුම් එකට ඉක්වල්. හැබැයි කොයින් එක බරයි. ඒක හින්දා ඉන්ක්‍රීස් වෙනවා. right? It got increased. Okay. And also there is a some kind of another point. So I take the scales like this. Scales is the final one. So I take the scales like this. So when it place, then I place the containers. I place the containers like this. All the cross sections are same. All the cross sections are same. And the water levels, all the water levels are same. Therefore, pressure on the lowest one, then when we take the readings of this one, right? Pressures on the bottom. Pressure on the bottom. I take this one A situation, B situation, and C situation. We get the containers, three containers which have in a uniform cross sections. All the cross sections are equal. So we place the same height of the water. Then we take in the scale reading. So we know what is the pressure created on the bottom one. P equals L rho G. P equals V rho G. P equals H rho G. No. P equals H rho G. P equals H rho G. So the pressure created on this one is P equals L rho G. P equals L rho G. Therefore, the reaction force coming from that one, and also PA, PB, I take L rho G, and this one PC, I take L rho G. All the lengths are equal, height are equal. Okay, heights are equal. So therefore, the force acting on the bottom also are same. Why? Pressures are same. The force acting on the bottom. FA equals PA. P equals FOA. F equals PA. Therefore, PA into A. LA rho G. FB equals PB into A. FB equals LA rho G. FC equals PC over A. FC equals LA rho G. So, force acting on the bottom one. FA, FB, FC. Them are also same. Therefore, readings of the scales are same or not? The readings of the scale same or not? All are same. Force acting on the bottom are same, but the scale readings therefore remain same. Okay, let's write down this one. Write down this one. Also write the forces. FB equals FC equals LA rho G. Write down this one. Then write down. It can be say the reaction force acting on. It can be say the reaction force acting on bottom also same, but the reaction forces but the scale reading not equal. Scale reading not equal. What is the highest load? This one is highest load. There is external water. This is also cross section A. This is also cross section A. But external water body in there. Therefore, if B equals higher, reading I take as R. Reading R B equals highest. then RA equals highest. Then smallest one is RC. You can see there is no water. There is no water. Lack of water in that one. So RC is the minimum. Okay. Write down this one. Scale radius. Okay. Write down this one. This is the end of hydrostatics. Okay. Write down.